Very few people would have been watching waves as much as I have. Over the last 40 years I've been developing a green energy system, long before the term green energy ever existed, just interested in how you can develop a safer and a better system to develop energy. One thing I have noticed is that the oceans can do anything. They can go from mild to extremely dangerous in a very short period of time. You could have a 5 or 6 metre sea with no wind and just big waves rolling in. Our system would deal with that, not a problem. But even down to a 2 metre swell, with a violent wind behind it, across current, things can get very ugly very fast. Even with our space frames and pins and hinge system, what do you do in those extreme circumstances? How do you protect, again, your investment and not see it destroyed because of the angry sea that you happen to be in? And it's more than likely 2 o'clock in the morning where nobody can or would want to go out anywhere near it to try and protect it. The answer is very simple. Your barge system at the back has like the umbilical cord where the pressurised water is leaving the barge back to the shoreline. Connected to that extract pipe system are pressurised lines coming back. One is a pump in and one is a pump out line. The inside of these tanks have a ballast situation. When the weather gets bad and it could hurt or damage your equipment, and the storms are so dangerous, it is better to put it to sleep. We do that by throwing a switch in the control tower and sinking the whole operation below the waterline. It can stay down there for 2 hours or 2 days. Pump the water out, pump the air back in, and it rises up to continue its job of generating energy. The reason for the buoyancy units on each cable will actually suspend this between the surface and the ocean floor. Another reason why you have to be in 60 metres of water. It is fully controlled, it is stable, and it can return back to work when the storm passes and there's still plenty of energy to be captured from that heavy weather system that's just come through. If you're following the numbers, you'll notice that as the wave height increases, the wave speed or number of waves passing per hour diminish. So it's a balance between the two. On a 1.9 metre wave, you fall in between a wave 2 and a wave 3 situation for your barge size. So a 1.9 metre wave passing every 6.3 seconds will deliver you 2.16 cubic metres. Every hour 571 waves pass, which gives you a total of 1,233 cubic metres. For barges, 4,932 cubic metres of pressurised water. On a 6-bar turbine, you produce 0.72 megawatts, and a 5-bar stored 0.57 megawatts. What happens when the storm exceeds your ability to protect it by how you've built it? No matter how much engineering you put into it, no matter how much metal you throw at it,
the storms would still do huge damage if not sink it.